Okay, let's get started. We're going to do law of sines. And then tomorrow we're going to do law of cosines. You guys should have learned this in geometry. You're going to use law of sines and law of cosines for non-right triangles. All right, non-right triangles. The instances in which you will use law of sines are going to be if you have a matching pair of angles as you do sides, right? So you have the same side as you do the angle. Keep in mind that the sides and angles are labeled opposite of each other, so A is always going to be directly across from angle A. B is going to be directly across from angle B. And then C is going to be directly across from angle C. All right, so these are always going to be labeled opposite of each other. If you don't have this particular case where you have a matching pair, then you have to use law of cosines, which we will learn tomorrow. I do believe we are giving you these formulas. Whoa, sorry, hang on. I do believe we are giving you these formulas. I'll confirm with Mrs. Meadows when I see her. Alternatively, you can write the formulas flipped. So if you think of it better as sine A over A equals sine B over B equals sine C over C, that's fine. You can write it however you want. However, this is how I'm going to write it today. Right, so that's how I'm using it. Okay. So in any of these problems, majority of them, we're not going to give you the shape. So you're going to have to draw it yourself. So let's start there. Let's draw this triangle. All right, so let's say this is our triangle. I'm going to say this is A, B, and C. We're given C is 102 degrees. Bless you. B is 29 degrees. And then we're given side B is 28 feet. Where would that go? Yeah, good, right? So B equals 28 feet. Okay. What's one piece of information that we can find? Yeah, very good, right? We can very easily find angle A, right? How would we find angle A? Good, right? So you can do 102 plus 29 and then subtract that number from 180. So when you do 102 plus 29, you should get 131. And when you do 180 minus 131, that should get you your angle A. So it should get you 49 degrees. All right, so I'm just going to write that down here. Measure of angle A is 49 degrees. And you can fill that in the triangle as well. Not super necessary as long as it's somewhere labeled. That's fine. All right, what else can we find? Or what's missing, actually? The two sides, right? Sides A and C. Not really much we can do here other than use law of sines. In this particular instance, we do have a matching pair. We do have side B and angle B. So we are going to use law of sines here. You guys can just copy paste it. I'm just going to write it out. Remember, it's going to be A over sine A equals B over sine B equals C over sine C. Let's start with angle A. Let's try to find that side, sorry. You're never going to use all three of them at the same time, so I'm just going to circle what I'm using, and let's cross out C. We're not going to use C right now. We're going to use it later. Let's plug in the information that we have. We have A over sine A, which is A over sine of 49. Equals B over sine B, so it's going to be 28 over sine of 29. How can we get a by itself? Sure, we can cross multiply. All right, so we're going to do this equals this. So he ends up with a times sine of 29 equals 28 times sine of 49. And then lastly, to get a by itself, we can divide both sides by sine of 29. And then a is going to be whatever you get when you plug this in your calculator. So plug that whole thing in your calculator. What mode should your calculator be in? Degrees. All right, we're not using any radians here. All right, and it says round to the nearest hundredth. So what do we get? Nice, 43.59 feet. Okay, good. What's the last thing that's missing? Good, side C, right? So we can do the same thing. Let's do law of sines again. This time we're going to use, we can use B and C. Let's ignore A. All right, so let's plug everything into B and C. And we're looking for side C. So I know that B is 28 over sine of 29 equals C over sine C is going to be C over sine of 102. Once again, you can cross multiply. This is going to get you 28 times sine of 102 equals C times sine of 29. And then you can divide both sides by sine of 29. All right, and then whatever you get when you plug that in your calculator is going to be your answer for C. So go ahead and take a moment, plug it in. And what do we get? Did we get 56.49? All right, so this triangle is solved. We found all the missing sides, all the missing angles. Okay, this next one's pretty similar, so I'm going to move along. I want to show you guys some interesting cases. I don't think you guys did this in geometry last year, but there's a certain case with law of sines where sometimes the information that you're given doesn't just make sense with one triangle, sometimes two triangles satisfy the conditions. Or sometimes the measurements that you're given don't make sense with any triangle. And so this is where we have to assume that there are two triangles, and we're going to have to check them each time, right? So this is the ambiguous case. You always have to check if there are two triangles when you have a non-included angle. Do you remember what an included angle is from geometry? So let's say I had a triangle right here, and I had A, B, and C. This is A, this is B, this is C. All right, let's just say I wanted to label these two sides, side A and side B. What is a non-included angle in this image? Any ideas? There's two of them. Okay, B and A, right? C is the only one that is an included angle, right? It's included between the sides A and B, right? A and B are not included angles or non-included angles because they are not between those two sides. All right, so anytime you have a non-included angle, so B and then A and B, or A and then A and B, then you're going to have to check for the ambiguous case. I'll show you guys how to do it. This is the visual of what some of these might look like. This is the normal case where you have one triangle. Sometimes it's a right triangle. We won't really deal with that right now. Sometimes there's no triangle, meaning the information that you're given doesn't make sense with any triangle. Or sometimes the information that you're given makes sense with two triangles. So we're going to do a couple of these. Let's start with this one. All right, so let's draw the triangle, as always, just so that we have a visual. Doesn't really matter how you label it. I'm just going to say this is A, this is B, this is C. A we have is 42 degrees. Side A we have is 22 meters. And then side B is 12 meters. All right, so angle A, is that an included angle or a non-included angle? Is that between A and B? Okay, so if it's a non-included angle, we're going to draw this little table. You're going to do this every single time you have two sides and then a non-included angle. So I'm going to draw triangle 1 and then triangle 2. We're going to assume that there are two triangles, and we're going to test if that actually is the case. So I'm always going to start out by drawing the angles, or listing out the angles. Angle A we know is 42 degrees. And that's going to be true in both triangles, right? Just because that's the information that we're given. All right, what other angle can we find with the given information? Yeah, right, we can find B because we have a side B. So let's use law of sines to find angle B. So I'm going to do A over sine A, so 22 over sine of 42. Equals B over sine B, so 12 over sine of B. We can go ahead and cross multiply. This is going to get us 22 sine of B equals 12 times sine of 42. Mm-hmm. Wait, what did I do? 22.
Oh, no, you wrote 27, I think.
20. That's a 2. My handwriting's not the best. 22. Okay, cool. Okay, divide both sides by 22. And then we get sine of B is equal to 12 times sine of 42 over 22. All right, this gets us sine of B. So what should we do now? Yeah, good. Do the inverse. So we're going to do sine inverse on both sides. And then this whole thing, when you plug that in your calculator, is going to get you angle B. Make sure you're super careful. A lot of times this is where people make mistakes, is plugging something like that in the calculator. Just make sure you're careful. Why don't we round to 1 decimal place? All right, let's not do 2. Let's just do 1 decimal place. What do we get for angle B? 21.4. Is that what we got? Good, so we get 21.4. That's fine. All right, 21.4. To test if there's a second triangle, you're going to do 180 minus angle B that you just found. Just stick with me. I'll show you what we're going to do with that. So 180 minus 21.4, what does that get you? 158.6. Let's just see if this makes sense with the triangle. What happens if I add A and B of the second triangle? What happens if I do 42 plus 158.6? What does that get you? 200.6. Does that make sense in a triangle? No, why not? It's over 180, so we do not have a second triangle. This is a normal case where we have one triangle. All right, I know it's a little tedious, and it ended up just being one triangle, but you have to check it every time because you want to make sure that you're accounting for all the cases. All right, are we okay with that part of it? So we found that 42 plus 158 is greater than 180, so that does not make sense with a triangle. Right? It might make more sense when we get one that is two triangles, right? But we'll do that, I think, in two examples. Gets us an answer. So there's no two triangles. We're just going to stick with our normal one triangle. All right, what other information can we find in this one triangle? The third angle, right? What is angle C? Nice. So we get 116.6 degrees. And then what's the only thing left that's missing? Good, the side C, which we can use law of sines again, right? Why don't we do B over sine B? Or you can do A, right? Let's do A, actually. So I'll do 22 over sine of 42 equals C over sine of 116.6. When you cross multiply, this gets you 22 times sine of 116.6 equals C times sine of 42, and then you can divide both sides by sine of 42. All right, there's no sine inverse or anything here. You're just going to plug this right into your calculator. Again, this is where a lot of mistakes happen. Just be super careful. All right, and then we should get 29.4 meters. So we found side C, angle C, and angle B. So this triangle is solved. All right, let me zoom out. Just because when you add this angle and this angle, it gets you a number that's bigger than 180. And triangles can never get you measurements that are bigger than 180. This is just the test for if we have a second triangle. If there was a second triangle, this number would be less than 180. All right, but we're going to get there. You're going to see what it looks like. All right, so let's try the same thing here. The next few examples are going to be a similar case where we're going to have to set up that little chart, but let's just keep drawing it. All right, so let's label everything that we have. I'm going to say that this is A, B, C. We know that A is 85 degrees, little a is 15 feet, and little b is 25 feet. Again, this is a side-side angle triangle, right? We have two sides and a non-included angle, so let's set up this little chart. We're going to do this every single time we have this particular case. And let's fill in the information that we have. We already know that angle A is 85 degrees because that's what we were given. All right, what other measurement can we find with the information given? Angle B, right? So let's give it a try. Let's do A over sine A, so 15 over sine of 85 equals B over sine B, so 25 over sine of B. As always, we can cross multiply, so this is going to be 15 times sine of B equals 25 times sine of 85. Divide both sides by 15. And then we can do sine inverse to get that b by itself, right? Because this gets us sine of b, not just the angle b. So we have to do sine inverse. Try that, see what you get. Are we getting anything here? Some of you look confused. Why? What happened? You got an error? Did anyone else get an error? What kind of error does it say? Like when you type it in, does it say like domain error or something like that? Okay, it should say domain error. If it says a domain error, that just means this number right here is out of the range. When you plug this number in your calculator, it should get you 1.66 something. Right? That is out of the range of sine. Sine is only between -1 and 1. All right? If you didn't know that, that's fine. You would have just seen the domain error, and you can establish that there is no triangle here at all. This triangle is not possible. This triangle does not exist. There's no triangle that exists that has these measurements. All right, I think one of the sides, the 15 feet, is going to be too small. It's not going to be able to reach the other side. So there is no triangle here. Doesn't mean you did anything wrong. It just means there's no triangle. Makes it easier for us. All right, you okay with that one? Okay. You can just write no triangle, yeah. I think on WebAssign, it gives you the option to type numbers in. But if there is no triangle, I think it wants you to write impossible for all of it. Impossible. It'll say in the directions. I think it says impossible, right? Impossible if it doesn't work. All right. Let's try one more. This is a good one. Same idea, same steps. We're going to label every side, every angle that we have. So A, B, C. A is 20.5 degrees. Side A is 12 meters. And then side B is 31 meters. All right, this is a non-included angle, so I'm going to draw the chart with the two triangles. All right, anytime we have this case, we're going to assume that there are two triangles, unless we find otherwise. The angle that you're given is 20.5, so I'm going to write that down. Angle A is 20.5 degrees. All right, you're given that, so you're going to write it for both of them. And then just like before, we can find angle B. So why don't we do that? It's going to be 12 over sine of 20.5 equals 31 over sine of B. We don't know what B is. All right, so this is going to get us 12 times sine of B when we cross multiply equals 31 times sine of 20.5. Divide both sides by 12, and then you're going to do sine inverse of this number right here. And that's going to get you angle B. So type this in your calculator, see what you get. I know it says hundredth, but let's round to 1 decimal place. What does that get us? Good, so we should get 64.8. So since we do have a triangle here, do you remember what the test was on this side? Good, right? So let's do 180 minus that number that we just found. 180 minus 64.8 and see what that gets us. What do we got? 115.2. Okay, and then what did we do here to see if it was a valid answer? Good, right? Add A and B and see if it gets you a number that's less than 180, right? When we add these together, what do we get? 135.7 degrees. Is that less than 180? Yes, it is. What does that mean? we have two triangles here, right? This number is less than 180, so we're going to do the same process just twice for two different triangles. I got that one from 180 minus this angle. And then that should get you that. All right, so let's solve it one at a time. Let's not confuse ourselves. We can go back to triangle 1. Let's start there. What is angle C of triangle 1? Nice, so we get 94.7 degrees. And then what's the only thing we're missing in triangle 1? Good, the side C. So let's use law of sines using these measurements of this triangle. So let's do, I don't know, it doesn't matter which one you do. I can do A. So I'm going to do 12 over sine of 20.5. Oh, that is A. Yeah, okay. Sine of 20.5 equals C over sine of 94.7. And then just like before, you can cross multiply. You end up getting C equals 12 times sine of 94.7 divided by sine of 20.5. So let's plug that into our calculators and let's see what we get. Okay. Nice, 34.2, good. 34.2 meters. All right, so the first triangle is solved. We did that, all right? Let's do the same thing with the second triangle, all right? What's angle C of the second triangle? Good, right? 44.3. And then we do law of sines again, just using those measurements. So I'm going to do 12 over sine of 20.5. I'm just going to use A equals C over sine of 44.3. So we should get C equals 12 times sine of 44.3 over sine of 20.5. Plug that in your calculator and you should get your answer. All right, what do we get there? Nice. In the second triangle, we had 115.2. Right, and I found that this by doing that. All right, so we're using angle B now, this angle B. So when you do 20.5 and 115.2, you get that number. Subtract that from 180 and you get this. All right. The reason we have a second triangle is because this works. Right, we have a number here that does make sense in a triangle. Right, these all are positive measurements. They add up to 180. So you have to account for both of them. Right, not always are you going to have two triangles. Sometimes you just have one, but you have to check it every time. Just in these cases though, right, the first two examples of this you didn't have to check. Again, guys, it's only when there's a side, and then a non-included angle in this case, right? If the angle is included, you would use, let's say you had angle C. Is that what you mean? Instead of A? Yeah. You would have to use law of cosines. That would just give you one triangle.
I'm like, what would the two triangles look like in this case?
That's a good question. It usually just means like, okay, let's say we know that this A is 12 meters. There's probably another 12 meters, like I don't know. I didn't really draw it the best, but let's just say that this is also 12 meters. This side just runs a little bit longer. Something like that. And it still has this angle. It still has this side, and it still has that side. My drawing isn't really the best. If you go to your notes, like if you scroll up a bit, where it says two triangles, you can see a visual of what that might look like. I think their drawing looks something like there's like an obtuse angle right here, and then another acute triangle right there. Something like that, where this is A, this is A, this is the same, this is the same B, and then this is A, angle A. Something like that. All right, it's good to visualize it. But here I just need the information, all this stuff. Good questions, though. All right, anything else? All right. Okay, the next two examples are pretty similar. You guys can give those a try on your own. I want to show you the area ones just because they are super quick. This is if you do have an included angle. Typically, everything's going to be labeled for you already, and you would just plug it into one of these three formulas, which, again, I do believe we give you guys. Again, I'll double check with Mrs. Meadows when I get a chance and let you know. But you're going to use one of these three formulas based on whatever information you're given. So let's look at these. We want to find the area of these triangles. Let's start with this one. We're given a B, an A, and an angle C. So scroll up. Do we have any formula that relates A, B, and an angle C? Yeah, right? Should be the second one that's there. So it's going to be 1/2 AB sine of C. So it's going to be 90 times 52 times sine of 102. Why the second one? Just because we're given a little b, a little a, and a capital C.
What? Doesn't say it.
Oh, don't scroll. You're on the wrong page. I scroll down to the area. That.
Oh, this one.
Yeah. So you're going to plug that in your calculator, and then you should get your answer right away. All right, so we should have gotten 2,288. To 2 decimal places would be 0.87. And the unit here is square meters. All right, pretty easy. That's all we had to do. All right, if you look at the next one, same thing, right? I have a little a, a little b, and a capital C. You're going to plug it into the same formula. So it's going to be 1/2 AB sine of C. So it's going to be 1/2 24/18 times sine of 80. Once again, this should just be one go in your calculator and you get your answer. And it should get you 212.72 square yards. All right, are we okay with those? Those should be pretty easy. The area problems typically are quicker. Tomorrow you're going to learn another area formula that also is pretty quick. But that's it for this lesson. Tomorrow we're going to do law of cosines and then the other area formula. So it should be a fairly short day tomorrow. Thursday, Friday we'll review. I believe your quiz is Monday. Just on these two lessons. So this and then what we're learning tomorrow.